Alright, the first part you had to match up with its inverse. Were there any questions on this one? Give it a visual. Well, over the line y equals x. Imagine them together over the line y equals x. This one was itself. And this is a good way to do this too. See this point 6, 0? Use your rule. When you interchange the x and the y, this is going to be 0, 6. So pick a point and interchange it. I usually use a point because I have a hard time visualizing. So this is my 1, 0. This is going to be at 0, 1. It's a good way to take the inverse. The inverse is interchanging the x and the y. So for you guys that weren't here yesterday, we talked about inverses, and they are a reflection over your line y equals x. Your line y equals x is right in the middle. And your rule is just interchange the x and the y. So if a point is up here at 1, 5, it'll be over here at 5, 1. And we do that for everything. The domain and the range interchange. In an equation, we swap them out and solve for y. So we were just looking at graphs to see where your inverses were. Stop me if you have any questions. Okay, then we wanted to prove if these were inverses. We wanted to prove if these were inverses. We said in order to do that, we do two compositions, g of f of g. Or if they write it as an inverse sign, then you do the f of the inverse. But if they're giving you two equations and they're asking you if they're inverses, they'll be named two different things. To do that, they have to work both ways. They have to come down to equal x. That's your line, y equals x. And as bad as they look, when you substitute one into the other, it usually gets rid of everything. So this cube to cube root, this cube root of a cube, this guy, be careful when you plug this in underneath, you get rid of it, keep the square root, square that one, then they reduce. And you can graph these, it's a good visual. Remember, you put them in your y1, put them in your y2, and in y3, put y equals x. It gives you a nice way to see the reflection. Or look at your table and pick an xy point and flip it so that you get a y and an x in another one. Questions? We have to do both of these because both the domain and the range interchange. 25, they were inverses of each other. Even though they had fractions in them, they were inverses. In this case, be careful because you have to distribute the two because there's two terms. The first two will cancel out of that denominator. The second two, we multiply. On some of your tests too, you're forgetting to distribute the second term. This first one, you're multiplying two things. So, if you factored out a 2 out of here, you can take out the 2, and the 7s will come out. Or just take the 7s out, you're left like this. And then maybe you can see the 2. Don't cancel out the 2. If you want to separate it, and you'll get x plus 3, or you want to factor it out. Either way will work. But don't cancel things out. That's terms. 45, is it a 1-to-1? 1-to-1 has to pass a vertical as well as a horizontal line test. So it does. 47 does not pass a horizontal line test. So its inverse is not a true inverse. You would have to restrict it. Tomorrow, we're going to restrict. We're going to say, okay, what part of this can I use to make me have a true inverse? Like you did with your trait functions. Tomorrow we'll do some restrictions. Today I just want you to get used to the inverse. This one also, not a 1-to-1. It doesn't even pass a vertical line test. So it's not a function. This guy, anytime you have a vertical or a horizontal line, it can't be 1-to-1. First of all, the vertical will fail and then not be a function. second of all, the horizontal, when you change the numbers around, will be the vertical. And now it's done. Question, Thomas? You didn't do these?
No.
Oh, okay. I probably took 55 out of there. Are you okay with the rest? Did you have 71? No?
You didn't even have to be
You didn't even have 51. So was this done? Did you have any of these?
Yeah. 71 and 72.
71, 73?
Great.
No 77?
No.
No, 77 we'll work on tomorrow when we restrict the domain. 71, make sure you interchange your x and your y and then solve again for y. And then last, make sure you take that y equals and turn it into the right notation for an inverse. X to the negative 1 at x. Make sure you turn it into the inverse notation. Interchange your x and y, solve for y. Good. Was that the end of it? The end of your homework? Any questions?